Everybody, in this video, I'm going to go through our lesson on properties of rational and irrational numbers. So the first thing I want to talk about are sums of rational and irrational numbers. Irrational numbers. So sums meaning you have two numbers, x and y, that you are adding, or maybe x plus negative y, which is really the same thing as x minus y. So sums also kind of include subtraction a little bit. So if I am adding a rational number plus a rational number, that is going to give me a rational number. So I'm going to abbreviate here. R stands for rational. I'm going to write that over here. So R is a rational number and I is an irrational number. Right. So if I have a rational plus a rational number, that is going to give me overall a rational result. So if I have, for example, 1 plus 1 is 2. This is a rational number plus a rational number, which gives me 2, a rational sum. If I have 1/2 plus 1/2, since these have the same denominator, this is the same as 2 over 2 or 1, which is another rational number. So a rational number plus a rational number gives me a rational number. A rational number plus an irrational number, which note that that's the same thing as an irrational plus a rational. You could flip it either way. But a rational plus an irrational is going to be irrational still. It's fine. If I have 1 plus the square root of 2, 1 that is a rational number, plus the square root of 2, the square root of 2 is an irrational number. That's like a decimal that goes on forever and ever and ever and ever. And if I add 1 onto that, it's still just a decimal that goes on forever and ever and ever. So this is an irrational number. It's honestly 1 plus the square root of 2. I can't even add those together. They're not the same radicands. I don't have like terms here, so that it's just 1 plus the square root of 2 still. Another example would be 1/2 plus pi. Pi is 3.14159. So that would be like adding on 0.5 plus this 3.14159 dot 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 dot. So that would be like 3.64159 dot dot dot. So another irrational number. So a rational number plus an irrational, and note that this is the same thing as an irrational plus a rational. They both result in an irrational sum. So what happens if you are adding an irrational number plus another irrational number? It is either going to be irrational or rational. Let's see if I can draw a better rectangle this time. That works. So we have two cases. We have that an irrational plus an irrational gives me an irrational number. So for example, the square root of 2 plus the square root of 2. these are two irrational numbers, right? I'm going to do this example in yellow, actually. But these are two irrational numbers, and if I add them together, really I have 1 of the square root of 2 plus 1 of the square root of 2, so that is 2 square root of 2, which is an irrational number. So an irrational plus an irrational can be irrational, or an irrational plus an irrational can be rational as well. Let's maybe underline these. So for example, if I have the square root of 2 and I add the negative square root of 2, here now I am really combining these like terms of 1 square root of 2 plus negative 1 square root of 2 and 1 minus 1 or 1 plus negative 1. That's really what that is. 1 plus negative 1, which is 1 minus 1, is 0. So we have 0 square root of 2. And 0 square root of 2, that is 0, which is a rational number. Because 0 over 1, that's a fraction. So it can be either or. Let's talk about products now. So products of rational and let me space that out a little bit, and irrational numbers. So now we are talking about products. So that is like instead of x plus y or x minus y, just x times y, which could often be seen as xy, just squished together. A rational number times a rational number, just like when we were adding, it's still going to give me a rational product. So a rational times a rational is a rational. If I have 1 times 1, that gives me 1. Or if I have 1/2 times 1/2, when you multiply fractions, you actually just go straight across the top and straight across the bottom. So this is 1 over 2 times 2, which is 4. 1 times 1 is 1, and 2 times 2 gives me 4. And both of those numbers, oops, whoa, both of those numbers are rational. Okay. If you have a rational number times an irrational number, that is going to turn out irrational. So if you have one rational times something as irrational, why is it when I get to this side that I have the harder time? For example, 2 square root of 2, which is note 2 times square root of 2. I meant to write that out a little bit better. 2 times the square root of 2, which can be written as 2 square root of 2. This is a rational number times an irrational number, square root of 2. And if you type this into your calculator, it's just going to give you this irrational result. So this is irrational. Also, if you multiplied 3 times pi, you just get 3 pi. Which is irrational. So rational times an irrational, which maybe you could write that also as an irrational times a rational. You can flip the order, but still, if you have one rational and one irrational, it's going to turn out irrational overall. Finally, if you have an irrational number times an irrational number, that could be irrational or it could be rational. So same as when we were adding again, it could be either or. So sometimes an irrational times an irrational number is an irrational number. For example, the square root of 2 times the square root, and let me do a different color. Square root of 2 times the square root of 3. That's really like the square root of 2 times 3, which is the square root of 6. And that is an irrational number. So sometimes you multiply two irrational numbers together, like the square root of 2 and the square root of 3, and it remains irrational. But sometimes you multiply two irrational numbers together and you get a rational result. So for example, if I multiply the square root of 2 times the square root of 2, that's going to be the same thing as the square root of 2 times 2, which is the square root of 4, or 2. And that is a rational number. So sometimes it's irrational, sometimes it's rational. All right, let's look at some examples. Is 3 square root of 5 plus 5 square root of 9 rational or irrational? So looking at this, I can't necessarily simplify or add these right off the bat, because they have different radicands, but perhaps I could simplify. So I have 3 square root of 5 plus 5 square root of 9. And 5 is a prime number, so that's not going to simplify at all. But I do notice the square root of 9, and the square root of 9 gives me 3. So we have the 3 square root of 5 plus 5 times that square root of 9, which is 3. And we can multiply now. 5 times 3 gives us 15. So this is 3 square root of 5 plus 15. And, we could also write this as 15 plus 3 square root of 5. And we have one rational number here, 15, plus an irrational number, 3 square root of 5. So overall, this is going to be an irrational number. All right, number 2 is the sum of the square root of 81 and 2 square root 16 rational or irrational. So this problem says, is the sum of the square root of 81 and 2 square root 16, is it rational or irrational? And ask yourself, what does sum mean? It means we are adding. So I want to add these two things together, and I can't add them right off the bat. They are not the same numbers underneath that radical. So now I'm going to see if I can simplify either of these, and I can. The square root of 81 can simplify to just 9. So I have 9 plus 2 times the square root of 16. And 2, or sorry, not 2, 16, the square root of 16 is 4. So I have 9 plus 2 times 4, and 9 plus 8, because 2 times 4 gives me 8. 9 plus 8 gives me 17. And 17, that's a rational number. I didn't even really need to find this number, I guess. I could have just noticed, hey, 9 is rational, plus 8 is a rational number, so 17 also has to be rational, or the sum. Number 3 is the product of 5 square root 20 and 6 square root 5? Rational or irrational? All right, so now we are finding the product. So product, okay. Product means we are multiplying. So I'm going to multiply 5 square root of 20 times 6 square root of 5. And actually, this one's going to surprise you because if I look at this, I notice square root of 20, that's not a perfect square. So this seems like an irrational number times 6 square root of 5. Square root of 5 is a non-perfect square as well. So this is an irrational times an irrational. And let's see what we get when we actually multiply. So multiplying here, remember you multiply your inside numbers together. So this is the same thing as, and underneath the radical, 20 times 5. And then outside the radical, we will have 5 times 6. So I have 5 times 6, which is 30, square root of 20 times 5, which is 100. And the square root of 100, we can evaluate that. The square root of 100 is 10. So I really have 30 times 10 here, which is 300. And I hope you recognize at this point, this is a rational times a rational number, which is going to be a rational, number. Last one is the product of 5 square root 21 and 3 square root 4, rational or irrational. All right, again, product means we are going to be multiplying here these two numbers. So 5 square root of 21 times 3 square root of 4. And if we're multiplying these two radicals together, we're going to start by multiplying those inside numbers together. So this is the same thing as 21 times 4 underneath our radical. And then outside the radical, I will have, 5 times 3. And 5 times 3, of course, is 15. So I have 15 square root of 21 times 4. What happened to this? I messed up when I was doing this problem in my notebook. That's so funny. But 21 times 4 is 84. And 84 is a non-perfect square. You could have done this in another way too. This is a non-perfect square, which means this is an irrational number. The other way you could have done this is notice that 3 square root of 4, square root of 4 is 2. So instead of 5 square root of 21 times 3 square root of 4, I could have had 3 times 2, and 3 times 2 gives me 6. So I have 5 square root of 21 times 6. And we have here an irrational number times a rational number. So that's going to be irrational overall. Please let me know what questions you have on this lesson.